Okay, there's our solution set. Our general solution is a linear combination of the vectors in the solution set. So general solution your xy function is C1 times this plus C2 times this. C1 times 1, 2, e to the 5t plus C2 times 1, negative 1, e to the negative t. Now if we have initial conditions, we can apply them so that C1 and C2 can be specified for a given situation. And I'll say C1 and C2 come then from initial conditions or boundary conditions. The problem that I solved has been stated without initial conditions, but if we have x of 0 equals 0 and x of 1 equals, and y of 0 equals 1, then we can solve this. So actually it's probably not a bad idea to go on and apply initial conditions to our solution. So again, we have xy equals C1 times 1, 2, e to the 5t plus C2 times 1, negative 1, e to the negative t. If, let's say, x of 0 equals 0 and y of 0 equal, I got x of 0 equal 1, okay, I'll do that. X of 0 equals 1, y of 0 equals 0. We should then be able to evaluate C1 and C2. Then x equal to 1, y equals 0 gives us a column vector. And if t is 0, then e to the 5t is e to the 0, which is just 1. Well, write e to the 0t. And of course, e to the 0t is e to the 0, which is 1, so that we have this. And how do we solve this? Well, we could write out a system of two equations. C1 plus C2 equals 1. 2C1 minus C2 equals 0. I'm going to immerse you in just a little linear algebra here. So it follows that this matrix times C1, C2 is going to give you 1, 0. And you can verify that. You multiply 1 by C1 and 1 by C2, so you get C1 plus C2 equals 1, which is exactly what you would get from the equation. You have C1 plus C2 has to equal 1. And similarly, 2 times C1 minus C2 has to equal 0. Well, you get 0 here, and you get 2C1 and minus C2. So that C1, C2 is equal to the inverse of that matrix times 1, 0. And this is the way you would generally solve it. Now, it's easy to invert that matrix. I'll probably mess it up if I invert it, and I don't want to take the time to do it because I want to talk a little bit about complex solutions. But there we have it. And whatever your initial conditions are, if they wherever they occur, whether they occur at 0 or one of them at 0 and one of them at equal 1, you're going to just get numbers over here, and you're going to get C1 times a column of 2 numbers, C2 times a column of 2 numbers, and you're going to be able to do this. So among other things, having written it in this form, once you've inverted the matrix, you could solve this for any set of initial conditions very quickly just by changing the numbers in this column matrix here, your target matrix. Okay, well, we want to talk a little bit about complex solutions, and I'm not going to do too much with repeated solutions because they act so much like repeated solutions for higher order equations where you just throw a t in there in front of your solution vectors. And we're not going to get into the reduction of order analogy and everything, because again, we're just doing a quick survey. But I want you to get this and then the complex solutions. So let's see how that works out.